Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is LeetCode number 3, longest substring without repeating characters. I would highly recommend you should read the problem statement and give at least 15 to 30 minutes of pure thinking to this question before jumping into the video. So I hope you have done what I said. So let's get into the solution. What problem is asking? You have to return the longest substring without duplicate character. Substring is, and also substring is continuous. It is not subsequence. Substring is continuous. So what if this is our test case? What would be the length is? A is first time B, first time C, again A. So the length till here was 3. Again is, let's see, A, B, C, again B. It was also 3. And so longest was 1. No, shortest was 1, longest was 3. We have to return this 3 while while doing this thing or segmenting the string. Did something strike to you while I was doing this segmenting, and I said again B appeared? Did something, did something. Now if it is not still striking your brain, you should practice LeetCode more. What I would say, do not get disheartened. Is, and it will be a sliding window. But it is not a normal sliding window because it doesn't guarantee that starting from here will always lead to starting from here doesn't guarantee that it always lead a maximum window. Why? Because let's have an example like this: B, C, D, E, and F. If you leave this A, and by including this A, you can get this much long string. And if you keep this A included, you will get this much of string. So by decreasing the size of window for this, and then again seeing if still A is present or not. Now A is not present at this condition. When A and not A, B and C are present. In this condition, sorry, it will not be a whole string. My bad. I just B and C, I just rewrote it again. My bad. Not B and C will not be there. Let's do it again. B and C will not be there. Sorry, my bad. A, B, D, F, G, H. So if we exclude this A and include this A, it will be a better result because of obvious reason. So it doesn't matter that you start. It does matter from where you start. Sorry, it does matter from where you start. So you have to keep your options open. That by excluding this, for example, or it can be B also. By excluding this also, can the window size increase? So we have to consider every possibility that if by decreasing the size of window, can can we get more? Can we get more? So I hope this much is clear. So you got the intuition why sliding window? Why sliding window? Because we need a substring, and substring has to be continuous. And when we are talking about continuous thing, then there is a window, always a window, that which we have to form. And by the condition given in the question, we have to decide of to increase the size and decrease the size. It is not a regular sliding window question in which you have to have k size of window and just keep iterating that k size of window. It is little different, that you have to adjust the front pointer little bit, and as a result of which it is not always a fixed length. So I hope you get this much, and let's dry run it again. Not dry run it, what will be the algo is, in order to have fast access of whether this much is present, we will be using an unordered set. Why unordered set? Because in ordered set there is uh, sorting. We do not need sorting. It will just increase our complexity. We just need fast access that can be done using set, and we will just iterate. We will have two pointer, not two pointer. Yeah, you can say two pointers. Start and end is equals to 0, while end is less than, that is the size, whatever the size of given vector is. And if in the set, if it is present, not present, if it is not present, carefully see, I have write a not present, then just insert. If not present, insert and calculate the answer. Why max? Obvious reason, because we want every time max. And how we calculate the current length? It's just end minus start. Plus 1 happens when the start is not increased. When both are increased, then we can, without using that, we can have end minus start. You can do it on pen and paper to know how when end minus start will work. You have to dry run it this much in order to understand. And else, what will be the case? We will, and also when this happens, we will also increase our end will also be plus plus. But when this happens, if it is present, this is present case, then what we have to do is delete delete this whatever is present at the start index and start plus plus. That's it. This loops will keep on running till this size, and we will get our answer over here calculated at every valid. This will calculate every valid window. Every valid window will be calculated and return the answer. And the answer, we can run this over this case, that given case, the given test case will be the set A not present, B answer is also updated, 1, 2, now it's 3, A is present, answer is still storing 1. Now start, end is over here, start is over here, start A is deleted, and star points to this. If A is deleted, now this can be inserted, and now again this A, I will mark it A star is inserted. Now again, what will be the length? Still 3, nothing changed. Increase E went to this. If E went to this, be present, what will we do? Delete it. Again, not present, B will not be present, it will be stored again, B star. What will be the size? Still 3, nothing changed. Pointer points to C, present, pop it, not pop it, delete it. Again, start was here. Now start pointing to this. Again, C will be added. Now again, it will point to B. B is still present. B star will be added, will be deleted. B hash will be added. I am just making these to help in identifying. They are same. B, but this time, start is pointing to A. A will be deleted, but still B is present. Still B is present. B is. Did I crossed B too early? Yeah, I did crossed B too early. This shouldn't be here. What will be there? B star. B star will still be present. B star will still be present. B star still present. Now S points to B. B star now B star will be deleted. And in other iteration B hash is included. This was correct delete. Now amendment was at B star. Now what is happening is S is over C. And again E points to B. Also the length doesn't change because it's just two size. Our answer is max, so max is still 3. Again CBB case, start was on this, he is pointing to this, start will deleted, will delete this, still point to B, still B is present, it will also be deleted, and start and S will point to same thing, this B dash will be added, and after that nothing happens, we get out of the loop, get the answer, and increases and again increases, we get out of the loop. That's it. That's the whole algo and problem discussion. Let's get into the code. As I said, the unordered set for easy and fast access, whether it is present or not. Just normal 2 pointers. Here I is start and J is end. If it is present, this is a inbuilt function of set, you can read about it. If it is present, insert, while inserting increase it and get the answer. You get it why is J minus I run is because we have already increased J. That's why that plus 1 is already handled over here. And while if it is present, just erase the, just start erasing from the start and also increase the start pointer. Here start is I and end is J. I am repeating again, and after iterating whole string, given string, just return the answer. Let's see if it is running or not. Yeah, it is running. So I hope you get this solution and understand what I am talking. It is a very basic problem to understand the variable size sliding window approach. So in the end, I would say dry run the solution, and our motto, keep grinding. And I would say you guys are awesome. And bye. See you in the next one. Bye bye.